Hey everyone, this is Matt with Learn Everything About Design, and in this video, which is part 2, we're going to be taking another look at this BMW E36 trim panel. So this goes around the shifter, and again, we're not going to be doing the full thing. The intent here for the user is to redesign a part that's no longer available for 3D printing. So we're going to focus our attention solely on the general shape, as well as this sort of middle piece. And the main reason I want to focus on that is because there are actually some challenges associated with it. This section here, where the 2 bolt holes are, that's actually fairly flat. But this other section here, it's kind of hard to tell. But so this section is flat or planar. This section right here is actually curved, except for this little bump out right here. So I want to talk about how to go about this, keeping in mind that this part is injection molded, so it has draft on everything. We're not going to be following draft because it's designed for 3D printing, or that's the intent here. So what we're going to do is we're going to take the surface we created in the first video, which again is an approximation of the geometry. There are some areas where I didn't stick true to the shape. So for example, if you look here on this side, it's a fairly consistent shape on the basically the edge where the shifter boot goes, but this section right here has a little bit more of a compound curve. And to get this, we really would need to go back into the freeform model and divide it up more and pull it down into those areas. And again, you can certainly spend more time getting it more accurate. For our purposes, I don't feel like that's really needed. It's close enough for what we need to do. All right, so the next step in this process, when we're trying to figure out how to go about designing a part to replace this, again, we always have to keep in mind the manufacture method, because designing for injection molding is very different than designing for 3D printing. There are going to be restrictions depending on the type of 3D printing. So if this is FDM, for example, then we have to worry about supports. If it's like an SLS process, or essentially a self-supporting process where we don't need to worry about supports, gives us a little bit more freedom. If it's a liquid-based process, an SLA process, we do have to worry about supports and removal, but that's a little bit different and not something that we really are going to design a part like this for, mainly because that requires us to be having these sort of vertical supports that hang it at an angle, and a lot of that's done in the slicer. So what we're going to focus our attention on is the geometry, keeping in mind that it is for 3D printing, but there are nuances there that you need to keep in mind. All right, so in QuickSurface Personal, there are a couple of approaches that we could take here. So one approach would be to try something like a fit surface. So for example, if we use the magic wand and we try to grab the geometry here and create a fit surface, in some instances, you'll notice it created this sort of like big bubble shape. But what we would be interested in is the area, let's see if we turn on analysis, the area where it touches the geometry. So you can see it touches in a few places. It's not super accurate, but this is one way or one approach we can take. Sometimes it works, sometimes it doesn't. The second thing that we could do is, if this is truly a prismatic type shape, we could simply go with creating the shape from this like top-down view and extruding it and getting our extrude or our shape that way. So that's another way that we could do it. And typically what we would do is use a 2D sketch, pull this up until it's cutting through the geometry. So find a position where it is cutting through everything. So maybe somewhere around there. And then we could extrapolate from there. So what I'm going to do in this video is I am going to approach it both ways, just so that we have the information. So that way we can talk about it. So this first way, if we're trying to do an extrude, keep in mind a couple of things. Well, one thing to keep in mind is that, again, the actual part is molded and drafted. So we're not going to exactly replicate that. We have to make some design decisions. If it is drafted in an extreme manner, so if it's textured and it has 5 degrees or more, then we have to kind of shoot for the middle and decide where we want to go. For our purposes, what I'm going to do is I'm actually going to grab the inside edge, not the outside, just because there's not a whole lot of data. We've got these little mount pieces and things like that. So the way that we're going to do this or start this is to clean up reference points. And so what this allows us to do is come in and clear out some of this geometry. This makes the selection process easier, especially if you're using something like Pro, where you've got the Sketch Assist, essentially an auto sketch tool. This can be really helpful to clean up the selection process, because when we're trying to select this, which we'll see in a minute, when we're trying to select this to extract some geometry, we don't really have a great way. Well, I shouldn't say we don't have a great way. It's not as easy to move and pan around the screen and just keep the stuff that we want. So oftentimes you have to hold down a shortcut key to temporarily disable the selection process. And then if we're trying to do that, plus hold down, let's say we're trying to hold down Shift and Control and pan the view to an area where we can get to the rest of the geometry, it just becomes a much bigger challenge. I think it's harder to manipulate and manage. So what I like to do, if I know that I only need a certain section, is I'll come and I'll do this cleanup first. I'll say okay, and this leaves me with just the part that I want. The next thing that we can do is we can either extract primitives. So for example, you can say fit curve, and we can just select everything that we have left and have it apply a curve. Depending on your requirements, you may find that you want to adjust the tolerance. So for example, instead of 0.1, maybe we say 0.01 and we reapply this, or we increase the number of points, for example. So you do have the ability to tweak and toggle these around to get to a result that works for you. Keep in mind that it is going to be an average, or it's a deviation based on these tolerance values. So what you want to do, I'm going to go ahead and go back. I'm going to say Control Z to undo, and I'll do this one more time. This time I'm going to kick the number of points up. Generally, we don't want to do this. The more points we have, the worse the curve is going to be. And the reason for that is because generally, if you can create a shape with, let's say, a 3-point arc, it's going to be better curvature than if you create it with a curve or a spline that has 30 points, for example. All right, so what we can see here is that we're going kind of inside, then outside, then inside, then outside, based on the number of points and tolerance. And so what I would generally do is I'd say try it. If it works, it works. For a part like this, when you think back to how it would have been designed, generally it would have been designed with arcs, potentially straight lines. So for example, if we grab the straight line here, hold down Control to snap. If I snap from here to here, you can see that's a straight line. So if we're trying to use a fit curve, going around that corner and trying to get it to fit in there, we're never going to get a perfect straight line out of it. The stuff on the side is not straight. You can see there is some curvature here. So this would typically, if I look at this and I was designing this from scratch, what I would typically do is go with a 3-point arc. The curvature is going to be much better. Again, holding down Control, allowing it to snap. You can see that looks pretty good. Same thing over here. And the reason the places I'm snapping are going to be essentially the start, end, and the middle of a curve. So imagine this was a fillet and these were extended out. Then that's kind of how we would approach it. Now what I'm going to do is I'm going to add a curve here, again holding down Control. It doesn't have tangency in the corners. We'll fix that in a minute. For this other side, what I'm going to do is use this corner trim, and I'm going to do an auto fillet, and I'm going to just drag around these. And what this is going to do is it'll automatically extend those two edges out. It'll apply a fillet based on the mesh section that we have, and then it'll keep tangency with those two intersections. So this is a much better way to do it if you've got a good reference. So I'm going to say okay. I'm going to go back to my cursor. I'm going to delete that, and then we're going to repeat that over here. So again, auto fillet. Again, auto fillet is going to be based on the mesh reference. Select those, and it does a pretty good job. We've got tangency, it's going to snap to the middle, and we've got a pretty good result. Over here, this is a bit different because we don't have anything connecting the middle here, so we have to kind of make an assumption. If I bring the mesh back, it looks like it's a straight line. So if I go from, let's say, here to that arc is probably coming out somewhere here. It may not be perfectly horizontal based on the orientation of the sketch. I would just have to assume where that arc's going to end. It's probably somewhere around here. And if I zoom in, maybe, let's say probably like that. All right, so the next thing I can do, again, we can use the extension option. If I grab these, it'll do a good job. I can go over here, get it to do that, and I'll say okay. All right, so that's the way that I would go about extracting this geometry. Again, you can use extract primitives. In many cases, it works okay. Since this had visually a combination of straight lines on the top and the bottom, and what looked to be large arcs on the side and consistent arcs on the corners, it makes more sense for me to do this somewhat manually to get it close. Now, I'm not going to have the option, when we go to extract primitives, we're going to have the tolerance. It's going to say you're within, 0.5 millimeters or 1 millimeter or whatever. We're not going to have that here. Just based on the way that we did this, but this is going to give us a pretty nice option. From here, what I would generally do is extrude this. Now, this is going to get a little tricky because, well, for a few reasons. It's going to get a little tricky simply based on the fact that we need to do some more manipulation to the geometry. So if I pull this down, I'm going to hold Control. It will allow me to snap to geometry. This might be better if I rotate it this way. So if I pull this down and I hold Control, it gives me this snap option. So you can kind of see I'm moving the cursor point around. One thing you're going to notice is it's not planar. This mounting face is actually at an angle relative to the direction that we're extruding. So snapping to geometry isn't going to really work here. So what I'm going to do is I'm going to pull this up so it's larger. I don't need that much on the top. And then we want to do this either as a new solid or a surface. So if we click on or deselect the solid option, what we're going to get is an open surface. If we leave it, it's going to be a solid. We can actually still use solid for trimming. It'll treat it as independent surfaces. So I'm going to say okay for that. And the main reason that I like to do this for this example is because now we can create planes to trim some of this stuff, keeping in mind that this is representing the inside. So what we need to do is actually offset it the correct amount. Now, the correct amount is going to be a little bit tricky, but there are some cool tools that we can use inside of QuickSurface that will allow us to help with that. So I'm going to select, let's go ahead and select the entire body. Let's see if we can do this. Select the entire body, and I want to offset it. So I'm going to use, basically start to drag this out. Let's go the other way. So as I start to drag this out, you can see that it's growing and it's starting to overlap right about there. There is an analysis option, which is pretty handy, and this will give us a pretty good indication about where we're crossing through that mesh. Now remember, I already said that this is a tapered part. It's injection molded. So if we're designing this for 3D printing, what we really want to look at is going to be the inside. So this is pretty good on this corner here. Let's go ahead and rotate this around where we can see it. It's pretty good on this corner here, pretty good here for the most part. It gets red on that section, but we've got a lot of green. So that's really what I'm looking for. The stuff in the middle is different because this bumps out slightly, likely due to the way it was molded. Obviously there's little features around here, so we're not going to hit all of this stuff, but I'm looking for essentially an average where I'm going to get close enough. So I'm going to say okay to that. Looks like 3.3 millimeters. And now what we have is a solid on the outside, or basically we've offset it outward. So we're able to extract the geometry from the inside edge, which had less features on it. So we didn't have these like ribs here. We didn't have some of these mounting tabs that, let's go ahead and come down here. We didn't have some of these mounting tabs that were intersecting with it. So it gave us a nice clean internal edge that we could pull that curvature from. And then we use the outside just by offsetting it to the right amount. And it looks pretty close to me. It may not be perfect, but it's pretty close. The next thing to do from here, I'm going to hide the surface for now because we don't really need it. I'm going to go ahead and save it because I haven't saved in a while. But the next thing that I need to do is I need to start trimming away or reducing the shape of this on the inside to match the mesh. And so the first thing I'm going to do is go to my main tab, or you can go to construct. We're going to extract a primitive from this face, a plane, look at analysis, And we can see that we've got a plane, if we look at it from the side, that's at an angle relative to the rest of the geometry. So this looks fairly horizontal here. This is obviously at an angle. So what we're going to do is we're going to create that. We're going to bring the solid back. I'm going to hide the mesh for now, but we're going to select this surface here, or the solid, I should say. It says offset surface. And then control select the plane. And then we're going to use trim. So when we do trim, notice something happens here. It doesn't work based on our selection. So I'm going to hit cancel. And with this, I'm going to increase the size of this. I'm just going to stretch it out a little bit and make sure that I have both selected. This is what I find to be a little tricky. Sometimes when you have something highlighted, it's not actually selected. But if you pay attention to what you see on the screen, you should see yellow highlights on all the edges. Now, once I have both of those and I hit trim, now it looks like everything's okay. So I'm going to trim away the outside of this surface and trim away the bottom of the box. And then let's see what we're left with. It's got this sort of inside edge, but I'm going to go from there. I'm going to say, okay. It looks like it failed. Why did it fail? I know why it failed. When we did the offset, it still has the stuff on the inside. So let's delete that. Yes, I want to delete it. And let's try this again. So plane, this, trim, get rid of the bottom. So you can see it's still keeping that inside that we had there. So what this is telling me, when I offset, I didn't use the option to remove the original, and I should have. So looking at this, before I go any further, I'm going to hit cancel. I'm going to go back to that offset surface and click remove original and say okay. So now when I go to my planes and go to my offset surface and trim, I shouldn't see the inside anymore. Yeah, that's much better. That checkbox should probably be on by default, simply because it still treats it as one solid body. But if you just go back, you can re-edit that feature and turn it back on. So now if we bring back the mesh, this should be close to that mounting tab. So you can see right there. The other thing that we need to do, however, if we hide the solid, is deal with the rest of this. And the rest of this is actually, I think, curved. So what we're going to do is a 2D sketch. I'm going to pick the, let's see, the XZ plane, rotate this around, pull this so that it's somewhere in the middle, say like that, and create it. Now the reason for that is because I think that this is probably just a simple arc. So I'm going to hold down Control, and let's go ahead, hold down Control over here, and create that arc so that it looks like it matches. All right, so now that we've got this arc, actually, you know what, let's, again, I'm doing this all on the fly, so anytime I'm messing around with this, I might decide to change or modify my approach. But what I'm gonna do is I am going to, let's pull this over. I'm gonna take this and extend it out on both sides. Let's go ahead and just extend that out. And I'm gonna create just a solid extrude cut. So we're going to come down. I'm not going to pay close attention as long as I've got essentially a solid body here. All right, so I'm going to pull this all the way until essentially that tab. Now, what I could do is I could rotate this around. As I'm pulling, I can snap to geometry there. And again, this is drafted, so it's going to have taper on that wall. I don't really care about that, but I'm going to say okay. And then I will hide the mesh and bring this back. So essentially now what we want to do is remove this body from this one. So we're going to select the body that we want to keep. We've got this cut option, which removes material from the base using another solid. And if we click this, it'll use it as a Boolean cut operation. And so now if we show the mesh, we should have something that is relatively close to these faces. So you can kind of see what's going on there. And then we've got this little a tab piece, again, that raises up. But for the most part, we can see a pretty good representation of where those mounting points are and where this face is. So now a couple of other things that we want to do is we want to turn that surface into a solid on the top, and we want to shell it. But let's go ahead and let's save this, and then we can take a look at the next steps here. All right, so I'm going to hide the solid, select my surface. I'm going to go to my surfacing tools. And what we want to do is we want to thicken this. So we're going to go thicken. And once again, we want to turn analysis on. And I'm going to start to drag this. And let's just go, let's pick an area like over here. Drag that up. And again, you're kind of watching in real time what the thickness is. So it looks like 3.7, 3.8. Yeah, 3.8, 3.9 looks to be pretty good. You can see it's pretty good representation there. We got some green there, some color coming through there. So again, this is another tool that you can play around with. You can see that, let's go ahead and pull this up. Pretty good representation there. I'm going to say okay. And now we've got a solid body that is essentially the outside shape. I'm going to hide the mesh. And then we've got this solid body that's the inside shape. All right, so next thing that we want to do is we want to cut the top here. Now we could do this with the surface before, but in this case, what we're going to do is, let's try to do a trim. So I'm going to select both of these. I'm going to say trim. I want to get rid of this top piece. And yeah, let's go ahead and leave the rest of it. All right. And then the last thing that we want to do is likely create a shell. All right, so I'm going to select this. Actually, let's select this whole body. And let's try offset. So let's try 3.7. Actually, what do we do? 3.9? Let's try 3.9 and preview. Might be the wrong direction. Let's try the other one. All right, let's reset it. All right, it's thinking. Let's try this. 3.9 preview. Yeah, it doesn't like that. Okay, no problem. This is actually pretty easy to deal with. So what we have is we still have our sketches. All right, so let's get rid of these. There's probably a good way to do it, but I might just be missing something. So we're going to take this sketch and we're going to extrude it. So again, that can cut all the way through, but what I want to do is bring it up to here. And we're going to offset it 3.7 down. All right, so it's going to be a new solid. We're going to say, okay, go to the side. And remember, we created that plane, but because the plane was used as a trim tool, it's actually gone now. But what we can do is we can create another one. So we're going to extract a primitive. We're going to create a plane. And then inside of here, just make sure that it matches. It looks okay. We're going to create it. And we can take this and we can actually offset it however much we need. So you can look at, again, the display here. You can snap, but I'm just gonna do it visually for right now. And then kind of pull that over. So what this will allow us to do is use that to trim this solid. Okay, so select both of them, select the plane, select the extrude. We'll use trim, get rid of that. That looks okay. Say okay. And then we'll select the original. We'll say cut. We'll select that body and we'll say okay. All right, so if we bring back the mesh, you can see now, you can remove a little bit more here. I'm not going to worry about that for our video. Again, we could play around with that cut tool and leave some of these tabs here. But again, you can always add them back if you need them. But this gives us a pretty good representation. Just probably one more thing I want to do is I'm going to create another 2D sketch on the top. And I'm just going to create these cutouts here. I'm not going to worry about taper angles or anything like that. I'm not going to be that specific. Just going to kind of go here, there, and we'll do the same thing on this side. So just kind of pick your first point, go there, and we'll say extrude. So Bring the other solid back and call this a cut, and we'll say OK. So now if we hide the mesh, we now have a basic representation. Let's rotate it around this way. We now have a basic representation of the part. Of course, we can round corners off and add fillets. But if we look at the mesh, you can see we've got the openings where we need it for the switches and extra pieces. We have got a fairly good representation. Again, the mesh, the original part, a lot of times when you see kind of areas like this where they're low or high, this could be surface finish issues with the original part. It could be shiny. Sometimes if you've got a matte finish part and then you've got shiny areas, those shiny areas will show up as high or low spots. So sometimes those can be problems. But overall, I think this is a pretty good representation. Again, you can definitely spend more time getting it closer. Obviously, some more work could be done here to open these things up. But again, if you're designing a part for 3D printing, in this case, if it's a desktop FDM, you want to spend the time and replicate the outside shape as accurate as possible. All the inside stuff, because you're not going to be constrained by doing things like injection mold draft angle or textures or things like that. You have a little bit more flexibility. So I would assume that this little slot here, these two slots, it's going to be some sort of mounting hardware. Of course, back on the back side, we do have two mounting holes, pretty straightforward. That's some mounting hardware. And then some of the additional tabs that you see here are going to be things that are likely press fit into other trim panels or pieces, and those can be added however they need to. You won't need to have the thin wall supports the same as you do for an injection molded part. You can put large fillets in the corners because we're not really concerned with things like consistent wall thickness. If it's an FDM part, you'll have to just play around with those features. So I'm going to go ahead and save this. I know that the first video ended up being about 30 minutes. 8 to 10 minutes was just talking about QuickSurface Personal. This video, about the same. We're looking at about 30 minutes. But hopefully that gives you a general idea of some of the tools and approaches that we can use, not just in QuickSurface Personal, but in LITE or Pro. Now, the approach that I took for this part, not necessarily how you would approach every part. I did some things the way that I did them, just simply based on the fact that we could explore the tools. So if we look at this part in general, we looked at doing things like creating a freeform for the basic shape. We looked at using both 2D and 3D sketches on the mesh to create other surfaces with the loft tool. We also extruded solids. We used trim and cut. And we extracted geometry and did some both manual and extracting primitives or extracting sketch curves from those mesh sections. So that's a whole host of tools, from 2D and 3D sketches to surfacing and freeform tools and basic CAD tools like extrudes and trims and cuts, things like that. So that should give a pretty wide variety of tool set that's needed to do parts like this. Now, if you have any questions on this or QuickSurface Personal or any of the QuickSurface versions, let me know. Remember, we are an affiliate, so if you missed the first video, you can use the code LEAD10. That will save you on whatever purchase of QuickSurface you're making. I believe it'll work on Personal. If it doesn't, let me know and I can ask about that, but I believe it is supposed to work on the Personal license as well. And again, we are going to be doing this part in Fusion as well. We're going to approach that more as a freeform body completely. And so, for example, in Fusion, I'm going to talk more about things like how to get those rounded corners using the freeform tools. We'll talk about thickening the freeform model. And we will do some basic Boolean stuff with solids and so on for the internal features. So the end goal is to have the same level of part that we have here in Fusion. So we're going to kind of approach it the same way. And so you'll be able to see the difference at. And then if we get a lot of comments or I have the time, I will also approach some of this with Plasticity, because I do get some requests for scan-based designs in Plasticity. So if you do want to see this in Plasticity, or obviously we're going to do Fusion, but if you want to see it in Plasticity, leave a comment and let me know that as well. So I think that's going to wrap up this video. If you have any questions or comments, please leave them below. As always, thanks for watching. We'll see you in the next one.